This video is a tutorial about solving from worksheet 2 scalars and vector problem 5. Now in this problem we are supposed to calculate the net force that is acting on the ball by the two forces of 300 Newton and 410 Newton magnitude. Now let's move on to the solution. First of all, we need to write the given. The first vector, we can call it vector A. It has a magnitude given 300 newtons and it has a direction. It makes an angle theta A equals to 60 degrees. Then vector B has a magnitude of 410 newtons and it makes an angle theta B. Now for the angle theta B, we need to pay attention that the angle theta is always the angle between the vector and the positive x-axis. So we cannot consider the 45-degree angle. We have to consider the supplement that can be calculated by 180 minus 45 degrees. This will give you an angle of 135 degrees. Then after this, we need to calculate the components of vector A, which are AX and AY. The same thing, we need to calculate the components of B, which are BX and BY. Now, for AX, we use the formula A multiplied by cosine theta A. Magnitude of A is 300. We multiply it by cosine 60. For AY, we use A sine theta A. Magnitude is 300 multiplied by sine 60. Now, the results for AX, 150 newtons, and for AY, it is 259.81 newtons. In a similar way, BX is B cosine theta B and BY is B sine theta B. Now, B has a magnitude of 410. We multiply it by cosine 135 and for BY, it will be 410 multiplied by sine, the same angle, 135. Result for BX, negative 289.91 newtons, and for BY, it will be 289.91 newtons. Now that we found AX, AY, BX and BY, we will use them to calculate the components of the resultant R, which is A plus B. First of all, to calculate Rx, we will add AX to BX, and to calculate Ry, we will add AY plus EY. For the first result, we need to add 150 plus or negative 289.91. As a result, we will have negative 139.91 Newton. This is the result of Rx. Then Ry, we will add AY, which is 259.81 plus 289.91. The result of Ry 549.72 newtons. Now we will continue by calculating first the magnitude of the resultant R. To calculate it, we will use R equal to the square root of Rx squared plus Ry squared. So R will be equal to Rx, we found it, negative 139.91 squared plus the answer of Ry 549.72 squared. The answer .24 newtons. Now that we found the magnitude, we need to find the direction. Of the resultant R. The direction of R can be defined by the angle theta R that it makes with the positive x-axis. It will be inverse tan of Ry over Rx. So it will be equal to inverse tan of Ry 549.72 divided by negative 139.91. The final result negative 75.72 degrees. So by the end of this tutorial, we learned how to calculate the magnitude and the direction of R, which is the resultant of two vectors A and B, which were given the magnitude and the direction in the beginning of the problem. Thank you.